The first technique we used on the dyno to begin tuning our fuel and ignition tables was the technique of steady state tuning. So in this section of our course, we're going to look at how we can apply this on the road or racetrack. So anytime in the main body of the course I talk about steady state tuning on the dyno, this is what we're going to be doing. And we're going to split this up into fuel tuning and ignition tuning because there are some slight differences as to how we apply both of these on the road or racetrack. We'll start by talking about our fuel tuning, and what we're going to be looking at here is how to apply the technique of left foot braking. So let's head out onto the racetrack and we'll see how we can do this. The first step of our steady state tuning process is to make sure that our engine has reached normal operating conditions. So we've already discussed this, we don't want to be making changes while the engine is heat soaked. So in this case I've just been circulating the track for long enough for our engine coolant temperature and our intake air temperature to get down to the normal temperatures I'd expect to see when I'm actually driving the car or racing it. So we're seeing 88 degrees engine coolant temperature and 22 degrees intake air temperature. The next thing I want to talk about is the gear that we're going to use for our tuning. There's no fixed gear that we must use for our tuning, but the gear that we choose will have an effect on the way the engine responds and also the speed that we're going to be going. If we choose a gear that's very low, perhaps first or second gear, what that's going to result in is a lot of torque multiplication. Now, particularly in a powerful car, this can make it much more likely that the car will end up wheel spinning. We're also going to be applying the brakes against a lot more engine torque, so this is going to in turn put a lot more heat into our braking system. The flip side of that is if we choose a very high gear, perhaps 5th or 6th gear, what this is going to mean is that we're going to end up at a much higher road speed by the time we get higher in the rev range. So generally I like to use 3rd and 4th gear for my steady state tuning process. So the steady state tuning process is simply a case of deciding on what engine RPM you want to be running at, and then using your throttle and your left foot on the brake in order to control the engine RPM as we increase our throttle opening. Just like on the dyno, we're going to be starting at our lowest possible load area. So let's just do this now, and we're going to perform this at 2,500 RPM. So what I'm doing is just getting the crosshairs on our software up to 2,500 RPM. So at the moment I've got my left foot hovering over the brake pedal, but I'm not touching it. So as I reduce the throttle, we can see that we can just get down to around about minus 70 kPa. This is actually the area where if I'm at that throttle opening that I end up at minus 70 kPa, I actually end up with the engine slowing down slightly. So even on the road I'm not quite making enough torque to keep us at a constant 2,500 RPM. Now the process we can use here though is we'll just simply start by accelerating a little bit beyond 2,500 RPM. We're just getting onto a straight piece of road now, and then we can drop our throttle setting and we're down to minus 70 kPa. You can see the engine slows down and we spend a little bit of time central in our minus 70 kPa zone so we can make changes to that. If I increase the throttle though, we can now move up to the minus 65 kPa zone. I can now hold the engine constant in that zone, and you can see that I can quite accurately do that. I'm just barely touching my left foot on the brake while I'm doing this. And you can see that on the road, unlike the dyno, the engine RPM will fluctuate a little bit. So at the moment I'm just going through a series of corners and over a bridge, so I'll stop my tuning process, focus on driving the car, and again get onto a straight piece of road where I can make my adjustments. So it is a little bit more involved than on the dyno where we can sit constant. Obviously if we have a very long stretch of straight road, then this makes our job much easier. We'll just get around one more corner and we'll go back to minus 65 kPa and 2,500 RPM. Right, so I'll just bring our RPM up now, and we can access again our minus 65 kPa zone. So you can see I can sit very accurately in that zone, and I'm just adjusting the brake as the RPM on the engine changes, and the throttle as I need to stay in the center of that zone. Once we've tuned that zone, we can increase our throttle opening and move up to minus 60 kPa. Of course, this now requires slightly more effort on the brake pedal to maintain our engine RPM constant, because we're now making a little bit more power. Likewise, we can now open our throttle further. We're going to come up to minus 50 kPa, and again we need a little bit more brake. And you can see that I'm just modulating the brake pedal there to keep our engine RPM constant, and modulating the throttle to adjust the load. Of course, as we adjust the throttle opening, this also means that the amount of torque the engine is making changes, so this requires us to also modulate the brake pedal. Let's increase our throttle opening now, and we'll come up to minus 40 kPa. So you can see that once we are used to this technique and we're comfortable with it, we can actually do a very good job of keeping the engine running exactly in the center itself. Not much different to what we see on the dyno. Let's increase our throttle opening further. We're now up to our minus 30 kPa zone. We'll increase our throttle opening. We're getting now almost to the point of wide open throttle or maximum power. Just allow our engine RPM to come up, so we're now central in our minus 20 kPa zone. I'll increase my throttle a little bit further, and you do start to build up a feel for how much additional brake pressure you're going to need to apply as you open the throttle further. So we're now at maximum throttle, and you can see that I'm holding the engine RPM constant. So anytime we refer to steady state tuning in the dyno tuning part of the course, this left foot braking technique is the technique we're going to be using on the road or the track in order to replicate that process that we're using on the dyno. We've now looked at how we can use the left foot braking technique to replicate the steady state tuning process that we use on the dyno. This is straightforward when we're tuning the fuel delivery, but I do need to discuss how we adapt this technique when we're tuning the ignition timing on the road. Now, on the dyno, we're looking at each cell in the ignition table, and we're optimizing it to MBT using the torque feedback from the dyno. As we've already discussed, this isn't possible on the road, so we're adapting our technique and doing this slightly differently. At this early point in our tuning process, what we want to do is simply ensure in steady state that the engine isn't suffering from knock at any point in our base ignition table. We simply want to make sure that our base table that we've used is safe. Now, if at any point the engine is suffering from knock, we obviously need to address this. We do this the same way that we would if we were tuning on the dyno. Later, once we've looked at the full power tuning process, we're going to discuss how we can then go about making adjustments to our ignition timing table in the lower load areas and reconfirming this in steady state. Let's move on now, and we'll look at the process of full power tuning on the road or racetrack.